Got started with forensics by going to InfraGard. Some people may know InfraGard because it got hacked by the Louise boat. But we have in Cincinnati we have like a forensics working group specifically inside of our InfraGard. And so I was like, oh, I want to know like what these guys do. You know, like how good are they at forensics? What do they deal with? What are like some measures that they come across? I never really got any good like presentations or materials from them. Most of the time they're like arresting people with like kiddie porn, which is good. They should be doing that. That's awesome. But at the same time, like I wanted to know like, you know, how good are these guys at forensics? So I started making forensics challenges. So like each month we would have a forensics challenge. If you make one, if you win one, you make one. So we did that for like a year. There were 12 forensics challenges. The FBI bros won 0 of them. Okay, so the next thing, Invaders Must Die. That's a song that I rap over. You'll see it tonight at 10 o'clock. But it's basically like, I will be offensive if you come into my house to try to take my stuff. So like, I won't react in like a strictly defensive manner. Like like there should be some kind of repercussion, some kind of counterattack. Crypto is good, no brainer, but I was thinking like, oh, maybe if I use it in a way that maybe they wouldn't think that most people use it, there might be some benefit to that. And then, does anybody watch Archer in here? Yeah. Awesome. We should hang out. All right, so Archer is always like classic misdirection. So that's another thing that we'll get into, basically getting forensic investigators on the wrong trail to look at the wrong things and waste their time. If you've ever like done a forensics investigation, you know it's very intensive on resources. It's like it takes time, it takes a lot of energy, you have to detail a lot of things, and so if I can waste their time, hopefully I'll be able to sit in jail and have a lawyer scream Sixth Amendment and due process and get me out of jail before the FBI gets my stuff. Some disclaimers, kind of the standard stuff. I've never done forensics professionally. I do reversing now. I did IR at my last job, and I've done application security in the past. Like I said, I go to the InfraGard meetings. I regularly troll the FBI, so we just keep trolling the FBI for great LOLs. Not an expert, YMMV, etc., and do illegal things. Everybody always says like, you don't do illegal things with this. It's your own fault if you get. No, just do illegal things. You're all getting arrested, the people that were clapping. Thanks
for telling the FBI.
Yeah. All right, so this first thing, the scenario is that like let's say the FBI comes to my house, right, and they're like, hey, we're gonna take your stuff. I'm kind of worried about external devices in two separate regards. The first one is like a live incident, right? So you don't just do hard drive forensics anymore. You don't just pull a drive and image it and then start going to town. You need your memory forensics also. It's a very crucial part of forensics nowadays. So that's the live part, is when they try to conduct memory forensics. And the boot part is dealing if they're trying to like to boot my drive or work on like an image of the drive. So asserting that the way that an investigator would load memory forensics, their tools would be through USB drive. When you plug a USB drive in, there's basically like two paths, two branches. You've got your mass storage, which is like your generic run-of-the-mill thumb drive that you go and buy at Micro Center or find in your parking lot or outside your company's door. And then there's a HID, which is a human input device. So when you plug it in, it registers as like a keyboard or something like that. And that's examples of those where you can do like the Teensy for that. The Hack 5 bros outside, they've got the Ducky. Iron Geek has his, I forget what it stands for, so I'll just say fucked. All right, so what we're going to do on the live side, my server at home is Linux, so I just did all my stuff in Linux. And in the sense of trolling, in consistency, I write C and x86 at work every day, so I thought it would be LOL to write all my tools in Bash for this. just as a warning. So on my Linux system at home, my server, I'm using UDEV. So UDEV you can use in Linux, and it fires events based on like what's happening with devices. Like the binary for the user land on the side of it varies from distro to distro. Like for me, it's UDEV ADM. I have a Debian Ubuntu based system. Some people have UDEV info. So what we want to do is say when a device gets plugged in, we want to find some way to validate. Like, is this a legit device? Is it okay? Like, is it mine? Is it my USB drive that I'm plugging in? Is it safe? Or is it not? So if it's not, treat it, be hostile, be offensive. So you can write rules for UDEV on how to act. So we've got the action is add. That means that the device is getting plugged in. And then serial is what we're looking at. This is like kind of the very basic approach to it. So we can say like, okay, this serial number, like the serial number on this device, it's okay. Like we'll whitelist it. It's solid. And the serial number on the second device, like that's cool. Like that's my drive too. So if those drives get plugged in, they're fine. Be nice. But then if not, like run this other program down here. Let's see. Oh, and this is what shoop whoop is. And that's just like the first iteration. I actually have another iteration that I'll show you guys. But yeah, it's basically just checking to see if it's an actual device. And if it is, it just writes zeros to the device. So goodbye to the forensics tools or anything else that was on there. Oh, and actually, I have a demo for this. So let's try that. Oh, yeah. Thank you. Sorry. I knew I put that in there for a reason. Is that more legible? Is that legit? Okay, cool. They didn't have over 9,000 for a font size. Oh, right, CD. Okay, so this is kind of what the UDEV rules look like, right? And we'll comment out this action right now with the shoop whoop. So I've got two drives here. Funny speaking, they're both property of the FBI. I kid you not, they actually are. So this first one, G, that's our good boy. So he's whitelisted, he's cool. This one is the foreign one that we don't know what it is. So we're going to take out the rules and like reset them, reload them real quick just so that nothing happens, and we'll just take like a quick image of the first few bytes on the drive to prove that like they're legit, and then we'll set the rules in and plug the device back in. What did I want to do? Okay. So we're plugging our device in. This is our foreign device, our potentially hostile device. And we're just going to show that like it's got stuff on it, like I'm not just starting with like an overwritten version already. And to do that, we'll just DD like the first K off the device. Pipe it to hex dump. And so we just see like, some zeros there, sure, but then like some other bytes, right? No big deal. That's just showing stuff is on the device. Cool. Okay, so now let's kick our stuff back into effect. Okay, so we've removed the device via VMware, but we'll emulate plugging it back in. And you can't see it, but it's flashing like crazy right now, indicating activity. And let's see if this will work. And now that's... And so all that the original shoop whoop was all zeros, but souse. We want, I was like, oh, zeros is funny, but it'd be more funny to write trollolololo. So yeah, it just builds out a string, uses the yes command to pipe the trollolololo string into DD, and it's 512 blocks, or 512 bytes per block, and it just writes in blocks of 512 bytes, trollolololo, over the device, nonstop. So, great LOLs.
Louise approves.
Louise approves. Nice. Okay, sorry, here's the breakdown, but I'm going to take a drink. Okay, so we whitelisted our own drives, our trusted drives in UDEV. The prefix that you saw in the file, 99-USB, the higher your number, the later that it runs in the process. So if you have like an earlier prefix, a lower prefix, you might end up hitting like a conflicting rule later on that overwrites the earlier one. Some drives or some distros, like if you don't put a prefix, then it always runs last. So just verify with your own distro first, do some testing on your own. Doesn't take any time, it's easy. The go-to USB at the end is like a jump in assembly, so we're just saying like once we've hit our whitelisted device, skip over the invader script, the shoot whoop script, and just bail out and start behaving normally. You're good to go. The %k parameter that we passed in the rule, this guy down here, like to the shoot whoop parameter, that's just like the device name. That's the device name that's given by the kernel. So we're passing that off to shoot whoop to say like which device to attack. And the original shoot whoop nulls the device. The one that I put on GitHub writes the trollolololo. And don't forget to change mode X because it's bash. Ha ha ha. Okay, so then I was thinking like, all right, no big deal. Like, say the feds know that, right? All right, cool. So what would I do if I was a fed and I knew this? Then I would just take one of int0x80's drives and put my forensics tools on those because he's only checking the serial number. All right, word. So I was like, all right, well, I should verify, the integrity of what's on the drive. So what we do is just kind of read in bytes off the drive and checksum them. So I've got these two scripts, herp derp and derp herp. And so derp herp herp derp just takes a device, so this gets piped in, and it basically goes through and checksums bytes on the device. Now, if you were like super duper paranoid, you could checksum your whole drive. You could image your whole drive, do a checksum of it. When it gets plugged in again, do another checksum, image it again, do another checksum. That kind of takes a while, especially if you have like a 16 gig drive, because I got a lot of hacks and I got to hide them. So what I thought would be faster is to just do like a Fibonacci sequence. And I mean, you can do anything. Like you could like do odds or evens or some other mathematical sequence, whatever. But basically, I just generate the Fibonacci numbers and then hit each of those blocks and grab the first 2 bytes off of them and dump them into a file and then checksum that file. So basically, what we're doing is creating a more sparse checksum, but it's still, I think it's enough that it's fast enough and still gets the job done. So nothing major. We're just putting it into a flat file, a checksum of our collected bytes and the device serial number. Then that way, when we plug the device back in, we can run the check again. And derp herp is pretty much the same code because it's doing the exact same thing. Dat serial. Sorry, I'm from internet. So yeah, we do the exact same thing. Take our Fibonacci sequence, grab all those bytes again, and then here is where it's different. So we say if the drive isn't listed, or if we don't find that checksum with that serial number, it's time for shoot whoop, time to fire the laser. So that's that. Oh, yeah. Does anybody watch Epic Mealtime? Yeah. Yeah. Jack Daniel's sauce. So yeah, herp derp as a signature. Now what's awesome about this is I'm pretty sure this is one I forgot to test, but I think that if your action is remove instead of add, it runs before you mounting the drive, before unmounting the device. So what you could do is have all of this automatically set up to go. So for your add action, you'd run herp derp, take your checksums, and then do the verification. On the remove action, when you're like getting done using the device, you set your new checksum to say like, okay, I'm done with the device. This is what the checksum should be when I plug it back in, and that way you can just verify it. P.S. Don't tase me, bro. Okay, does anybody have any questions on that stuff at all? Yes?
It's with this checksum stuff, so you're assuming that you're only ever using that one USB drive with the one machine that you're flipping in and out. Have you considered, any sort of way, is there any sort of way that you can think of maybe to be able to use it on multiple machines, or?
Yes, yeah. So the question is, what if you go to your friend's house and like copy a bunch of torrents from them and then plug the drive back in at your own system? Definitely the checksum will have changed. In that case, you just go in, disable the UDEV rules temporarily until you can get a new checksum on the device. Any other questions on the live stuff? Cool. Okay, so for boot stuff. So at home, I've got like a little track top, little 900A with a Backtrack 5 on it. Big ups to the offset guys. And so I've got, my whole thing is like I have an encrypted partition just on the drive, and like that's it, that's all on the drive. So you can't boot off the drive in my laptop. Instead, I take the kernel, the init RAM disk, and the key to decrypt the drive, and put those on separate media, like a USB drive. And then what I do is boot off the USB drive, boot into BusyBox, and I actually found a way. Everything I find online says you have to type in a passphrase to decrypt that, which means you could like get beat up by the feds to give up your passphrase. But I found a way that I can actually feed in a key file to decrypt the drives. So my key file is like random bytes. I don't even know what the key is to decrypt the drive. So I kind of thought about this in two ways, right? Let's say you're facing this situation where they want your netbook or your laptop or whatever. You can play nice. So it's kind of like a TSA setup, right? Like I'm just going through the airport, bro. Like I make rap songs about hacking and stuff. So yeah, just going to my shows, no big deal. So instead of like just one encrypted partition, what you could do is just like put Windows on a front partition and still have your encrypted partition behind that. That way when TSA bro is like, time for gate rape and go through scanner and then also boot your laptop, you just boot it up, no problem, boots Windows, everything looks legit. In reality, still, all your sweet stuff is like encrypted on that second partition back there, and you can still boot off your USB drive, boot your kernel and everything like that. Everything's cool, playing nice. But then I was like, yo, play for keeps, right? So, what if you just say like, no, I'll just keep my one partition, but since I'm booting off of removable media, my kernel is on a separate device, I really don't need the MBR. I don't need those first 512 bytes, right? So my first partition is offset somewhere further on the drive. The code that initially runs when you boot, the first 512 bytes, like I don't really care about those. I'd never run that code. I just run off my USB drive. So I wrote this, lolz assembly, it's just 16-bit stuff. And so what it does, finds the start of the first partition, loads up the bytes for the letters T and R, then loads up the bytes for letters O and L in separate registers, and writes the first two, so TR onto the start of the first partition, and then loops O, L, 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 O, L. And so just watch while the feds try to boot your laptop. I haven't checked with the EFF. I don't know if this constitutes destroying evidence, but technically they're the ones that booted it. They ran the code, so. But what's cool about this is like the bytes are being overwritten at that point. Encrypted data is being overwritten, so even with your key, like you won't be able to decrypt everything. So that's kind of funny. Poker face. And so this is kind of like doing like a little bit of forensics with this. Before I ran that MBR, I just found the offset of the first partition using parted, and so it says like, yeah, it's at this offset 32,256. And then afterwards, after running the MBR, I took an image starting at 32,256 and that's what's on the device at that point. So, yeah, so, you skeptical, bro? Yeah, maybe, like, probably won't get my door kicked in by the FBI. Like, I think the worst thing I do is troll the FBI. I don't know that that's necessarily illegal. But, I mean, there is the Patriot Act. You do get administrative searches when you go through the airport, and I fly almost every weekend for shows, so, it's whatever. But not everybody has, like, necessarily the same background that I have. So, I used to run 2600 in Cincinnati, and I started that when I was just out of college. And the generation before 2600, before I took over, or the generation of 2600 before I took over, had an incident involving the FBI. So these two guys got arrested, and they had like done some hacking. They had some credit cards and all this stuff. So knowing that, like I was like one of two people giving talks at 2600 pretty much every month. The other guy was like giving sweet network talks. I was always giving like, here's how you write this exploit, and here's how you hack into this, and stuff that's kind of offensive. But I wasn't doing anything illegal. But just knowing that, I was thinking like, yeah, I'm probably on like a short list with the FBI for network intrusions that have anything to do with Cincinnati, Ohio. So then I was like, yeah, like I want to see what these bros can do, right? Go to the InfraGard. And so I had submitted, my paperwork, and I went to an InfraGard meeting, and there was like a new cyber special agent guy there, and I was like on the way out the door, like I'm just leaving. This is all in passing, and so they're like, oh yeah, like this is Dan. I'm like, hey, I'm David. And he's like, cool, nice to meet you. And then like that was it, out the door, and I left. I went home. So like maybe 6 months later, I'm at a Reds game with like some of my coworkers at the time, and the cyber SA is there as well. And so I see him and I'm like, oh, hey, what's up, man? Like, I remember meeting you real briefly, but I don't remember your name, sorry. And he's like, oh, I'm Dan. It's like, cool. And he's like, you're David. And I'm like, yeah. And he's like, and your last name is, and says my last name. Not cool, bro. So yeah, so like I go to InfraGard and just kind of like drop stuff like this, and it's all warning shots, It's like, don't come and take my stuff, please. And like once you get in there to do forensics investigation, it'll be like a war crime in there. So just don't, please. Yeah. Over 9,000 booby traps. Boobies. Cool story, bro. Riveting tale, chap. Okay, classic misdirection. I wanted to talk about like two different aspects here. Basically, in either case, we're trying to run the forensic investigator down the wrong rabbit holes or up the wrong trees. So file carving, just like a real brief general overview of file carving. You take like an image of a device, and every file format that's like well documented has like header bytes. So you can tell the format of a file by looking at the bytes in the header. Some people or places call it a magic number. If you check out the magic file on Linux or ever use the file command, like that's what it's doing. Some formats have defined footers. And so what you're doing is you're iterating across that image, and you're finding the header and optionally footer bytes to carve out the files as they're defined on that device. Because we all, maybe we all don't know, I don't know. But if you go and like you remove a file from your file system, right, you click delete, put it in the recycle bin, RM, whatever, it's just technically being unlinked from the file system. The bytes are actually still physically on the device in almost all cases. And so that's why file carving works. You can take a device where stuff's been deleted and still recover the files that were removed from it. So I was thinking about it, and I'm like, okay, yeah, like classic misdirection, documented formats have headers. Okay, so some of them, almost all formats, have binary file content, right? Executables, like you look at a exe in a hex editor, you look at a JPEG in a hex editor, you see like a bunch of bytes that don't really make any sense. I'm sure there might be some strings in there, but it's all just binary content for a lot of it. So I was like, oh, well, what if we just slap a random file header on some random binary content? Like, is that legit? Like, does it work out? Y/N? Most cases, no. And this is why you can't, like, let's say I had like a zip file header on some random data. Like, zip file has like a structured format. You can't extract that archive. You can't like render a Word doc that's just random crap with like a PK, MS Office header on top of it. If I just throw a JPEG header on some and JPEG footer on some random data, like it won't display. So like it doesn't really work out just to randomly throw bytes around and throw headers and footers there. What's funny though about that is like, let's say that you like carved out, over 9,000 JPEGs off of a device. It actually takes a human to go through and look at each of those corrupted or random JPEGs that like there's nothing there. There is no picture, and so that's kind of funny because it wastes time. But I think humans can process like massive numbers of pictures in short time. So it's just kind of funny. Like computers can't tell that that's a bad JPEG file, but you need a human intervention to do that. So file carving, random data like plus header, why work. But what about encrypted data? It's supposed to be random. It's supposed to be binary. It's not supposed to display anything or render anything. So, all right, yeah. What else could we use? Like 7-zip, we can use RAR, we can use GPG. These all have defined file headers. So we can all tell like, yeah, that's a 7-zip file, no doubt. And they all use encryption. You can't see like inside of them. If you actually like put a password on a zip file though, you can see like, oh, these are the files inside the zip format. So, or inside the zip archive. So in this case, I just did 7-zip RAR and GPG. So this is kind of the classic misdirection thing. So first off, you take like your files that you care about and you encrypt those and, drop the encrypted files on the file system, whatever. Then you make random files of random data and you encrypt those. And all of these with like big passwords. And then you delete all the encrypted files. So that way when you go through and carve everything out, you just get like a metric buttload of encrypted files. And there's no way to tell like, ooh, this was the ODay, but this one was just random data. Because it's all encrypted. And it's all encrypted with a really big password that would take like infinity years to crack, hopefully. So the investigator carves all the encrypted files out, can't tell, what was originally good versus like what was just crap. So GLHF, you mad bro? He mad bro. How much pollution do you need? Can you find enough files? Like in my dual core directory that's got like all of our tracks and like, I don't know what else we have in there, just stuff. 15,000 files. In my laws pictures directory, just from like browsing 4chan over the years. 3747. You could do like a deb bootstrap and like grab stuff, free files, 8857. get some website, you get over 9,000 files. Okay, so let's see. Yeah, okay. So this is a herder another bash script. You just pass it a directory and say like, hey, go find every file in that directory and just encrypt it with a random password. No big deal. And then this one's fun. I don't know if you guys can read it. Ring, Proggy, to troll FBI forensics bros. Ring, for those that don't go on 4chan, is requesting. So requesting Proggy to troll FBI forensics bros, sauce blocks, or source please. And then the summer guy, are you mad? I am a troll. So let's take a look at those real quick. Same thing that I just showed on the slide, really nothing there new. I think this is a little different. You want to sync the file to the file system first so that when you remove it, it's not just getting removed out of memory. Make sure you flush the write buffers out or so that they write to the device. Because that's like, you want all these files to like hit the drive so that way when they do their file carving, they're pulling them back up off the drive. Sweet. Yeah, so do a file is our main workhorse function. So what it's doing is you pass the dir script a number of parameters and basically say like the number of iterations that you want to do. In each iteration, it randomly picks like how many files we're going to generate. One thing that I was worried about, because like I suck at math, but like some people in the government are like really good at math. And so they could say like, oh, like all files of like, 5K are like, these are the randomly generated crap files. So just disregard those, in which case like our whole point is lost. So I try to make everything as random as I can, because that way it's like it's hard to tell, like you can't just, there's no pattern to derive. So So yeah, we pick a random file size. For our random password that we're generating for our random files, I'm just passing it through SHA-512 sum. So your key space for your passwords that are encrypting these files are 16 to the 64th, which comes out to be like 10 to the 77th. So that's one with 77 zeros after it. I mean, that's good. It's a lot. If you wanted more, you could do like base 64 instead, or you could like do more bytes through base 64. But I figured 10 to the 77th is over 9,000, so it's big enough. So we've generated our random file, and we've created a password for it, and then we just randomly pick like what extension or like what format we want to encrypt the file with. So we'll randomly, like, statistically speaking, a third of them would be encrypted with GPG, a third of them would be compressed and encrypted with RAR, and the other third would be compressed and encrypted with 7-zip. Either way, these are all random data getting encrypted with big, long, random passwords. So that, and it's over 9,000 files on each iteration, so that when they all get carved out, you're faced with like this whole heap of encrypted files, and you're stuck like, okay, where do I start? Oh, and then we securely remove the original file, so that you can't just say like, oh, I see all this crappy random data. Pick dir. That just selects it builds out subdirectory structures randomly as well for sweet file metadata stuff, file system metadata stuff. Sorry, that doesn't look it looks a lot cooler in smaller font, I promise. But yeah, nothing major. That's all we're doing there. Dir. Okay, does anybody have any questions on the file carving stuff? Yeah, that's an awesome suggestion. Thank you. The suggestion is basically to have a more realistic file size generating algorithm or approach, which I like, because you're definitely trying to blend in and you're trying to obliterate the signal to noise ratio. And so anything that lets you cut out a fraction or a portion of the dynamically generated files is like definitely working in opposition to that. So I like your suggestion. Thank you. Any other questions with the file carving stuff? Yes.
Are there any file types where you can basically constantly go into a loop as far as processing data? I ran an issue with some like Nissan data formats where I tried to recover a database and I generated like 3 terabytes out of a 100 meg database. So are there any cool techniques to use file types like that?
Yeah, so the question is asking kind of like about just basically causing problems when they try to extract the file type or work on it. So, like, would a comparable analogy be something like a decompressing an archive that just like expands like horrendously? Okay, yeah. So I don't know to answer your question, other than just the like hacks that I've seen on compressed archives. But there are some bugs where you can make a compressed archive, and then like when you go to decompress it, it just like decompresses into like a horribly sized expansion. So yeah, sorry, I don't know for sure to answer your question. I do know like when I did like my PDF malware analysis stuff a long time ago, you could do stuff where you could like abuse the PDF format to like have a small PDF, but when like when Adobe Reader rendered it, it like blew up over 9,000 in memory. So man, we should make a drinking game. Like every time I say over 9,000, we all get drunk or something. I don't know, man. All right, abusing stego. So steganography is you take like a cover file, like an image or a sound file, and then you hide something, you hide a stego file inside of that. And so when you go to look at the image, the host file, it still renders fine. You go to play the audio file, it still plays fine. That's how I like actually hide a lot of stuff in dual core tracks. If you rip the albums to waves, and you have to go buy the albums first. The pirated versions don't have them. No, I'm just kidding. But a lot of people use Stego just at a base level to try to like. It's not my mic. I don't feedback like that. They try to use Stego just to hide stuff, at a very base level. But that's it. They're like, yo, I got Stego. I'm set to go. And I mean that's supposed to be the approach. You're not supposed to be able to find that people are hiding things. But there's a whole other process called steg analysis that I won't dive into. And the whole point of that process is to find files where steganography is being used to hide things. So I kind of took the same approach, saying like, yo, classic misdirection, except doing it with Stego is kind of cool, right? If the forensic investigator can determine that a file has something steganograpically embedded in it, holy crap, I should like get drunk and try to say that, it'd be fun. If they can determine that something is embedded in there and they can recover that first embedded file, like they're probably going to stick on that trail of like trying to figure out what that file was that was embedded into it. So same thing, like generate a random file and encrypt it or compress it, and then embed it into a cover file. Kind of with your point on like your ratio and stuff like that, I was like, well, if every single JPEG on my system and every single wave on my system turns up with like positive steg analysis, they're either going to be like, yo, our Stego thing is broken, or like, man, he's just trolling, like he just put a bunch of crap in here. Or they might be like, holy crap, like there's a bunch of stuff and now we're stuck with the same problem of having to figure out, what's legit and what's not that's embedded. So kind of determine your ratio, sparse versus dense. You can randomly, do like a mod 23 or something to like only assure that like a certain number of files get like embedded with your random files and everything, but whatever. You pick your own ratio. So then I've got this, I think this is the last one. Pixar didn't happen is the other script. Just full of these. Okay, so naming convention is awesome. Do a Stego. So what we do is we just, we pass in a host file. So like you pass in like a legit wave or a legit JPEG cover or a cover file. Generate a guest file name based off of that. We pick like a smaller file size for the guest file size to embed into it. Generate the random guest file. Again, use another random SHA-512 to encrypt, or to, we're going to use actually the random pass is to encrypt the random data. And then, this is like the bait part. Then we get another password from a dictionary list. And we use the dictionary password to embed the encrypted file into the JPEG or into the wave. So that way they can crack the Stego like super easy. And they're gonna be like, oh sweet, yo, like I've got like these 300 JPEGs that had like 7 zip files embedded in them. Quick, let's get to cracking them. But they're all like SHA-512, some protected, and they don't go anywhere anyways. So it's either just, chasing the wrong trails. Like, little do they know, all my stuff's in Singapore, no extradition laws. But yeah, so then we just embed that stuff in StegHide, shred the original, and that's it. That's pretty funny, I guess. Me gusta.
So is it your intent that this steganography will be distributed?
Yes, with those, like, because we want to lead them on, right? So we don't want them to just be like, oh, whatever, like, this is some stupid picture of int0x80 rapping. Yeah, great, another, wow, this guy really has a lot of pictures of himself rapping. But like, in the end, they're like, wow, he like embedded some data here and he embedded some data there. And instead of just being like, waiting for stuff to churn, whatever, we kind of just lead them on so they don't just give up on that part. Because while they're trying to figure out that line, they're not like looking for the good stuff, hopefully. So that's kind of most of the real content. There's a bunch of other crap you can do that's kind of fun. Defragging is good because like it moves stuff around on the file system, so you can overwrite like certain bytes and potentially remove traces of certain files or portions of traces. It doesn't really cost you anything. You can like background the process in Linux, or just kick it off with an at command or an at job in Windows. Rename high value files, this one I like. So like does anybody use KeyPass? Does anybody use LastPass? Ha ha, Kaz. His name's Kyle, everyone. So with KeyPass, you can, like store all your passwords for your accounts and everything in this encrypted file. This is a single file, which also has a defined set of bytes for the header. So if you image a device and I've got a KeyPass database on that device, you can carve out the KeyPass database if it uses those same 7 bytes for the header file. If I go in and change KeyPass, yay open source, if I go in and change KeyPass and recompile it and say like, yo, don't use those bytes for the header file, use these other bytes, then do you think the forensics bros are going to go and RE my copy of KeyPass to be like, oh crap, he's using these other bytes? No, well, they probably will now, but but anyways, yeah, so we evade carving. They don't find our good stuff, right? That's the whole thing. We don't want them to find the good stuff. So we don't want them to find the KeyPass database. Other things you can do, exploit the investigators tools. A couple of my friends that I used to work with at NeoHapsis, they gave a talk at DerbyCon, and they basically had an ODE on a library that was used by both NCase and FTK. So you would put your exploit in a piece of evidence that was in a case inside of NCase or FTK, and then when the investigator goes and examines that piece of evidence, their box gets hacked. So that's kind of funny. The payload was actually really awesome in the demo. It was a laughing skull that bounced around the screen that one of my friends, I think it was Chris Necker, coded it, and so that was really funny. He had some more nefarious ideas on what to do with that, which was good too. Full disk crypto, we all know and love, but the problem with that is attacks exist for it, so you can do cold boot if you guys have ever read the paper on that. You can basically dump the key out of memory, dump memory, grab the key, and decrypt the drive. You can do evil made if you guys have ever seen that, kind of like tampering with the MBR, and you basically set up so that everything looks normal. You type in your password, but what it's doing is it's hooking one of the functions at the very end and redirecting execution flow off to another function. So when you type in your password for TrueCrypt to decrypt your full system, it stores that password off somewhere. The evil maid comes back in later and retrieves it back out. And of course, any of us who read XKCD know of the brute force crypto with the $5 wrench. That works as well on full disk crypto setups. And nuke it from orbit is the only way to be sure, because that'll ruin a forensics investigation like none other. So I'm dumping all the source for all these bash scripts, LOL, up onto GitHub. There's a really cool white paper out on internet that kind of got me first interested in forensic stuff years ago. It's called How to Exit the Matrix. It's about network forensics investigation. It moves around across different servers, so just Google for it. It's pointless to put a URL in there. On Twitter, I'm dual core music, so you can tweet at me, but only if you're saying nice things. Otherwise, I'll just be like, no, they said nice things. And you can always reference the Sky News computer security experts. They know everything there is to know. Does anybody have any questions or any requests that aren't rap music related? Yes?
So rather than actually encrypting or compressing the files, why didn't you just make a randomly generated file, write the magic number with the checksum for that format on it to speed up creation?
Okay, so make a randomly generated file, write a magic, write the magic number header bytes signature on it, and then do what with it?
And just make sure the checksum matches to whatever that particular type of file is. Like a bar, it's got a checksum for the data portion or whatever. You don't have to do it full compression.
It doesn't cost anything to run the RAR on that. I guess if you had a ton of files that you were RARing all at the same time, you could just background it and fork them out and let them have at it. But yeah, I just figured it was nice and easy in Bash to just run the RAR command itself. Yeah, that's about it. Yes.
I know you're preventing them from inserting USB drive in the machine, but if they use another means, how would you protect the
Sorry, the question is, how would you protect integrity of the memory on the system if they weren't using just USB drives? And I don't really have a good way in that case. So if they just broke the box open, turned a can of compressed air upside down, blew it on the memory, pulled the memory out, stuck it somewhere else. Nah, I got nothing. Physical security is kind of a crapshoot, and I suck at it anyways because I'm 5'8" with like 120 pounds and a mustache or something. So, yeah, like I got nothing else on that. Like, and if you do something else like FireWire DMA attack or something, like I got nothing for that. So, yeah. Yeah, pull the plug. One thing that's actually that they mentioned in the How to Exit the Matrix paper is you set up 2 boxes, and one does like a heart rate monitor, and so basically as soon as like one of those boxes drops off, you like start wiping the other box because the assertion is that like they grab that like the front box, and so eventually they'll find the box with like the good stuff on it. So you just start wiping yourself anyways. I guess that's one way you could do it. I've heard of like boxes put behind like drywall and stuff like that, and like hole in the wall and all that crap. Not that way. No. Sorry. Yes, sir.
Maybe use a case alarm, right? To trigger something. You just start writing arbitrary shit to memory.
Yes.
Evidence charges, there might be a concern. Right.
Yeah, the question is like using a case alarm, and again, like I don't really know much about physical security, like, and I know for a fact there's a lot more like tamper and anti-tamper stuff that is beyond like what my brain comprehends. So I don't know. I'm a byte monkey, like just ones and zeros. So, but it's definitely a possibility, and it would work too. Like possibly like FBI comes in, they open the case up to do the compressed air, and like all of a sudden everything's gone. Yes.
One of the like fun rage tools they have is a device to plug in that basically still moves the mouse around to keep the machine from locking. So if you're doing a live rate, the machine can lock the desktop, right? So if you can you could have a tool to match that USB ID and then wipe the disk when you see it. You basically let them wipe their own disk when they plug their tool. So if anyone knows what USB ID that device is, please share.
What you do is you start making little tinsies and keep changing the vendor ID randomly, and you can make a little mouse jig look pretty. I have code that I showed in the class the other day. I'll have it on my website before long.
Cool. So any device that you recognize, wipe.
Yeah, exactly. Yeah, and so that's the approach. Like we whitelist and checksum and everything, but.
That's when we look at your keyboard, figure out what the keyboard is, and come to the environment if it is before we plug in a jigger. Okay, I don't think people are going to do that, but just saying, it's kind of.
But that's a good point because like what was it? It was a Microsoft Coffee thing, and then there was like the decaf or whatever that came out, the anti-kit. So yeah, it's all cat and mouse, which is really fun, and that's what keeps it entertaining and everything like that. Also, big ups to Iron Geek. I know that he did like an anti-forensics thing as well, and I tried to not use anything from his, so that except give him shout outs at the beginning. And I think were there any other questions? Cool. I'll see you all tonight at 10 o'clock for rap musics.
Okay, cool.
Sorry, they're doing video touch-up, but everybody else can do whatever.